Math 287, Cuesta College. I'm Joe Vasta, and we have come to the end. It's kind of a weird place to end it, which would be 9.1. You'll see why this made sense. The first few homework problems are a review. I would strongly suggest doing them. They are going to be systems of differential equations, not written with matrices, but just kind of written out, and you're going to write out the matrix and solve those linear systems using the methods from the last three sections that we did, which was 9.4, 9.5, 9.6. You really don't want to use the methods in 9.1 because they're clumsy methods. They're just kind of introducing this, and when I used to do 9.1 first, people got confused by the time we got to 9.5 and 9.6 because there were different methods, and 9.4, 9.5, 9.6 is the most efficient way of doing these problems. Okay, so make sure you do the first few homework problems, and then the last few, like the last 5 or 6 or whatever, have something to do with linear systems, which we're doing, first order linear systems. That's what we've been doing, and taking higher order single differential equations and converting them to a first order linear system. So this is kind of neat because we can take something that's more complicated and convert it to something that's first order, but it's going to be a system. So what do we have here? Right here we have a third order differential equation. So that's what we have there. So let's see what we're going to do. I'm going to go ahead and call this first guy right here x1. Okay. Then I'm going to call the derivative, so its first derivative, x2. And the second derivative, I'm going to call x3. So this one's a simple one, a basic one here. Now you might say, well, are we going to call the third derivative x4? No, the highest derivative we do not label with an xi. Okay, so take a look at this. What I'm going to do is I'm going to go ahead and say, well, what is the derivative of x1? The derivative of x1, okay, so x1 is y. Its derivative is y prime, isn't it? Which is x2. And I'm going to do the same thing here. I'm going to say x2 prime, the derivative of this guy. So what is the derivative of y prime? It is y double prime, which is x3. Now the tough one is going to be this last one. So what I'm going to do is I'm going to say, well, what is the derivative of x3? Well, it's x3 prime, which is y triple prime. So this is going to be written as 2, I'm rewriting this equation, 2x3 prime, because you see that that's what that is, and then I'm going to keep all the blue stuff. I'm not going to have any y's now, so this is minus 6x3 plus 4x2 plus x1. This equals the sine of t. Okay, so another piece of paper. We're almost done writing out the solution here. We're going to put this in the normal form. We're going to put this with the derivatives on the left-hand side. So that's all I have to do now. I'll switch it over to black ink. I have x1 prime equals x2, x2 prime equals x3, and then can I solve for x3 prime on that? And yes, I can. I can bring those guys over. So, I mean, when I solve for x3 prime, I have 2x3 prime equals, so this is going to be negative x1 minus 4x2 plus 6x3 plus sine t. So what I want to do is I want to divide everything by 2, and so what I'm going to get is I'm going to get x 3 prime equals, and I'm just going to read that off over there, this is going to be negative 1/2 x1 minus 2 x2 plus 3, so I'm looking at that, 6 over 2 is 3, x3, and then plus 1/2 sine t. There's my answer. So, you know, the question was, convert to a first order linear system. There it is. Now, we're done with this problem. So now what I'm just doing is just for the math majors and the people who are interested in this. We could say what we have here is we have x prime bar equals ax bar plus, that's not a plus, plus vector b, where our matrix x looks like this. So this x right here, x bar, is just x1, x2, x3. So our matrix x looks like this. In the first equation, I don't have an x1, I have an x2, and I don't have an x3. In the second equation, I do not have an x1, I do not have an x2, but I have an x3, so I'll put a 1 there. In the third row, or third equation, I have negative 1/2 there, negative 2 there, 3 there. That right there is matrix A. And right-hand side vector, right-hand side vector, vector B, is going to be, now I don't have any functions of t over here or over here, but I do have one there, so this is going to be 0, 0, 1/2 sine t. Now, x bar is really just x1, x2, x3. So on your own, you could verify this. You could put an x1, x2, x3 right there, multiply it through, add it to that, and you'll find that this right here is described by this matrix and this vector. But in your homework, all they want you to do is write this right here. Okay. Let's go do another one. Before we do another one, I'm going to hit you with a theorem here that says every nth order differential equation where you can solve for the highest order, the highest derivative, and there's a function, a multivariable function. It just means I can solve for that. Every nth order differential equation can be reduced to a first order linear system in normal form. Normal form is the derivatives are on the left hand side. So our instructions are convert to a first order linear system. So what am I going to do? I'm going to do the same thing I did on the other problem. I'm going to go ahead and say, oh look, I've got y's. I'm going to call the first one, this one right here, is x1. Now here's a common mistake people do. They circle the second one and they say, okay, we're going to call that x2. But x2, there is no y prime in that equation, but it still exists because you need y prime to get y double prime. So x2 is actually going to be y prime. So here is x3, which is y double prime. And do we have a y triple prime in the equation? No, we don't. So I'm going to say x4 is y triple prime. And that's where I draw the line in terms of putting those little tick marks. Once we have 4, I just put a 4 up there in parentheses. Some books will use Roman numerals. They just don't like people. I don't know why they put the Roman numerals. So we do not circle that and call that x5, the highest derivative. We leave like that. So when I go ahead and write out my answer, I know that x1 prime is really y prime, which is x2. And x2 prime, which is really the derivative of that, which is y double prime, is x3. And x3 prime, which is, this is x3, so x3 prime is y triple prime, which is right there. That's x4. And x4 prime, I left a little space there because this is the one where we're going to have to work to get the answer. So let's go ahead and say the answer will be put there, and then we'll put x4 prime. Because x4 prime is really y quadruple. We're not going to say that. We're going to say the fourth derivative. This right here is x4 prime. You can see that because here's the third derivative, there's the fourth derivative. So what I'm going to do is I'm going to write out that equation there. This says 3 plus x4 prime plus 7x3 minus 5x1 equals the ln of t. So now I'm going to just solve for that, put everything else on the right hand side of the equation, and I'm going to write the answer there. So x4 prime is 5x1 minus 7x3. Okay, so I took care of those. I don't have any x2's in that equation. And then I'm going to have minus 3 plus ln t. And so if you were to write a matrix A, the matrix A would be 4 by 4, which would be 0, 1, 0, 0, and this would be 0, 0, 1, 0, 0, 0, 0, 1, and this would be 5, 0, negative 7, 0. And your right-hand side vector, vector B would be 0, 0, 0, and then this, negative 3 plus ln t. But they didn't ask us to do that, and so this completes problem number 2. Let's go ahead and do problem number 3, which happens to be our last problem. This is the last problem of the class, so if you've made it this far, you've gone pretty far. So before we do the problem, we want to make a little note here. There's a theorem that says that most systems of differential equations can be reduced to a first-order linearly. I'm making up new words. There we go. Let's get rid of that. First-order linear system in normal form. Okay, so this is going to be a little bit trickier than the other ones, but all these problems I'm just doing some substitution. So let's go ahead and start off. I have x's and I have y's instead of x1s and x2s, because that would make it like really confusing. So this right here, okay, our last one, I didn't write this down, but I should have. This last differential equation was a fourth order differential equation, in which we turned it into a first order linear system. Okay, so we took a single differential equation and made it into a linear system. This guy right here is not just a single differential equation anymore. This guy right here, we're going to look at the highest derivative, and the highest derivative is the second derivative. So that's what we're going to call this. We're going to call this the second order system of differential equations. Now, had this x double prime would have been an x triple prime, and everything else was the same, then this would be a third order system. So the order is the highest derivative that you see. Okay, so let's go ahead and see if we can do this problem. Before I started off and I pointed to y and I said that was x1. So I'm going to point to x and I'm going to say that guy's going to be x1. Okay, now there's a few ways you can take this. I'm just going to go, I have to just pick one way. I'm going to go ahead and circle this y, and I'm going to call that x2. As long as I don't circle the highest derivative and call it an xi, I'm doing good. Now I'll go back to the x's, the first derivative. I see the first derivative right here. I'm going to circle that one, and I'm going to call it x3, because I already have an x2. And then do I have a y prime? I have a y double prime, but y prime still exists, so I'm going to let x4 equal y prime. Okay, so the highest one, so this right here and this right here, those are the highest derivatives. So we're not going to call them a new xi, but we could see that y double prime equals x4 prime. And so we have an x4 prime there, and then this guy right here, x double prime, is going to be an x3 prime. Now, all this is a substitution. And so what am I going to do? I am now going to see if I can write an equation or a system of equations. I'll just use black ink here, where I say x1 prime equals x2 prime equals x3 prime equals x4 prime equals. There's my answer. You're like, hey, can I put that? Can I do that on the test? There's my answer, and there's nothing there. No, you can't, but that's where my answer is going to be. So x1 prime, here's x1. x1 prime is going to be x prime, that equals x3. Oh, before we move on, some of you would have preferred to call x x1 and x prime x2 and y x3 and y prime x4. So it, you know, tomato, tomato. I almost did it that way, and I decided to do it the way that I did it. Okay, x2 prime. Well, x2 is right here, and x2 prime would be y prime, and where's y prime? It's x4. Okay, these guys right here, they are going to be the pain, okay? So look at this. I have two differential equations, and the first one has two green things, which means two highest derivatives, one on x and one on y, and then the second one has just the second derivative of y, and it doesn't have the second derivative of x. So I'm going to go ahead and write out that equation, but without the y prime or without the y double prime and the y. So this is negative 2. Oh, and by the way, there's an x there. So you know what? I'll circle that in blue, and we can see that x is x1. So it's just negative 2 x1 plus x4 prime plus 2x2 equals 3t squared. So in this equation, I can solve for the x4 prime, and I'm not going to have any other derivatives in that equation. In fact, that's the only derivative I have. So when I solve for that, I have x4 prime equals, what is this? This is going to be 2x1 minus 2x2 plus 3t squared. So I'm going to go ahead and put that right here. So maybe I should have just put it right there. 2x1 minus 2x2 plus 3t squared. Okay, so now I have that, and I want to rewrite the first equation, and the first equation is going to allow me to solve for x3 prime. Here is x3 prime, but I also have an x4 prime, which now I know what it is in terms of things that do not have derivatives. So let me go ahead and write that equation here. So this is x3 prime, I'm using the xi's, minus x3 plus 5x1 plus 2, and then this is an x4 prime, but now I know what x4 prime is. So this is going to be times 2x1 minus 2x2 plus 3t squared, and this is going to equal e to the t. Okay, so now I just have to solve for x3 prime. We'll distribute the 2. So x3 prime minus x3 plus 5x1 plus 4x1 minus 4x2 plus 6t squared equals e to the t. Okay, we know we're going to put together these guys right here. We'll have 9 of them. So because I'm running out of space, I'm going to go ahead and write this up in the answer. I am solving for this. I'm putting this guy all by himself, so I'm going to have minus 9x1. And then what about my x2? So I'm going to have plus 4x2. And then, let's see, a plus x3. So I have a plus x3. So that takes care of all those xi's. And then I have an e to the t. And I'm not going to forget about that 6t squared, so it's going to be minus 6 t squared. And whew, this we've just taken a second order system, which we haven't had a second order system in this class. We converted it to a first order linear system. We could draw out the 4x4 matrix A, and we can also draw out the vector B. We don't need to do that in our homework. That finishes this class. So I will do a little review on the next time, but this is what I'm going to be doing partly on the review. On the last review, I had this differential equation and had initial conditions, and I used annihilators to solve it. I used the variation of parameters to solve that differential equation. So now what I'm going to do, or not this time, but the next on the review, I'm going to use the Laplace transform to solve that, get the same answer, and then I will then convert this second order single differential equation into a first order linear system, and I will solve that first order linear system, translate my answer back, and get exactly the same answer. So these four methods can solve this differential equation, and we'll do that for part of the review. So this concludes 9.1, our very last section. Keep up with the homework. Have a good day.